start the demonstration of the tungsten-based device. And this device is one of 4 that Knowm has that we basically developed for Knowm to try and get some interesting properties they were after for their particular application. And when they saw this, they decided to try and sell the devices to other researchers so that more people could have access to them and we could all start learning more rapidly about how these things work. So they created a nice system for actually testing these devices with a nice test board, and that's what Tim Wolter is going to come up and connect. But this test board and the resistor, or the Memristors, are available, and hopefully people will start learning a lot about them, and we can really expand our knowledge. Knowm also offers the back-end of line processing option with Memristors. If you wanted to pick one with your IC, they would set you up for that. And the board that Tim's going to bring up looks like this. So this is the Knowm Memristor Discovery Board. And you can see the Memristor chip is here. It's got a really nice socket with a switch to take it out. Memristors are sensitive. These are 2-terminal devices. They're really sensitive to handling. So it's a nice, safe way to handle that chip. And he connects it to a Digilent analog discovery system, which actually acts as an oscilloscope and pulse generator, things like that. And it just goes directly into your computer. So he's written some software to interface the Knowm board with this and to do a demo. And what we're going to look at is the frequency response of a memristor of the tungsten doped, showing the pinched hysteresis loop. So we'll be kind of setting that up live and changing frequencies and amplitudes and watching what happens. We're going to do a quick on-off switching test where we don't really have a DC sweep available on this particular setup. So what we'll do is we'll decrease the amplitude of the sine wave to something like 100 millivolts peak to peak and just give it a DC offset to show you can make the device go on or off to high or low. And we'll do a little bit of pulse testing afterwards. So with that, let's come up, and he's coming up. I do want to take this time, because I might not have time afterwards, to acknowledge grant funding from the Air Force for most of the device design, except for Knowm's design, which was funded by Knowm. My core student Colton was the cold temperature student, and I didn't mention I made him redo the experiment 4 times because we saw strange things, so the poor guy had to really redo it a lot. Kyler Palmer on STDP and Beth on the metals selenide. Professor Chua, because I've had a lot of good, interesting suggestions on measurements and learned a lot from what he's provided. And Art Edwards has been doing the theoretical calculations.